Let's have a look at the another reaction mechanism of haloalkane, that is haloalkane getting converted into amine. Now I would think that I have got haloalkane means CCl or CBr type of group. Somehow it is getting converted into CNH2. By the way, this reaction mechanism is in the second year, so if you are looking this at the first year, do not worry about it, but it is good to know the mechanism even at the first year level. So here this is the amine group. So amine group can be as a NH2 or it can be as an NH, where here there are two carbon attached to the nitrogen. Now I would think that, well, I have got this CbCl or Br and I have got this NH2. What type of compound or what type of reagent can give the nitrogen and hydrogen? Think about it. Yes, you are right. So here the reagent that you need is ammonia. Now when I use ammonia, and you already looked at a couple of mechanisms, so you know that how it is going to work. But if I dissolve this ammonia in water, then ammonia will act as a nucleophile and attack on the haloalkane, but at the same time the solvent which we have used as a water, it is going to give me some amount of H plus and OH minus. So what do you think of? This ammonia going to act as a nucleophile, as well as the OH act as a nucleophile. And as you already looked at the first mechanism, if the OH act as a nucleophile, it is going to give alcohol as a product. Do we really want mixture of product? I would say no. So the reagent that you use is definitely ammonia, but that is dissolved in ethanol. You will come across many mechanisms at a level that if you want a reagent to act as a nucleophile and if you want to prevent OH from the water acting as a nucleophile, then it must be dissolved in ethanol. Okay, so make sure that you remember this very well, because this will be a key point in the mark scheme too. Now, what is the condition for this reaction? Now, generally when we carry out the reaction, yay, presto, yes, we use reflux all the time. Now, ammonia is a gas and we can dissolve ammonia in ethanol. But when you heat it up, it has got low boiling point and it will come off from the top of the condenser, and cold water is not good enough to keep it in the liquid state. So the condition that you used is sealed container. That is, we are going to use this as a sealed container, and we use just one more thing, excess of ammonia. We'll discuss why excess of ammonia at certain points. So remember three key things. You use excess of ammonia, dissolved ethanol, and you need sealed container to carry out the reaction. This reagent and condition get checked quite a few times in the exam, so make a note of it. Now let's have a look at the reaction mechanism. So you have got excess of ammonia. Ammonia has a lone pair of electron. Chlorine is electronegative, therefore it is delta negative. This is delta positive, so the dipole has formed as usual on any haloalkane. So this lone pair electron in ammonia attack on the carbon delta positive as a nucleophile, and the reaction goes in the same way as other mechanism, but slightly different. I'm not saying difficult. So you have got ammonia becomes the part of the molecule, and Cl has came off. Now, any nitrogen compound, it make 3 bonds and it will have the lone pair electron, and that is the beauty about the nitrogen. Nitrogen make 3 bond, carbon make 4 bond. So when I look at here, this particular nitrogen in the intermediate, it has lost the lone pair electron. As it has lost the lone pair electron, making a bond with carbon, therefore it developed the positive charge. Now it's not a neutral compound, and that's why it's not stable. So what hydrogen will do is, hydrogen is going to give a bonding pair of electron back to the nitrogen to make it stable. So nitrogen is always happy when it has got the lone pair electron, and therefore hydrogen is sacrificing itself and it is giving the bonding pair electron to the nitrogen. Now let's have a look. So nitrogen get the lone pair electron, but in this process the hydrogen has to leave, as it is breaking the bond to give up the bonding pair electron back to the nitrogen, and we got Cl minus. Do not write as a HCl final product, because in the mechanism we need to show all the species separately, so do not add them up. It is not a chemical equation, it is the reaction mechanism. So here you got NH2, that means you got the amine compound, and how many carbon? 1, 2. The compound belong to amine family, and here it's a ethane amine. We got 2 walls together, so remove E, therefore it's a ethanamine. And that's all about the mechanism. I would say this is 1 mark, 2 mark possibly. This is the 3rd mark, final 4th mark. So this is one of the mechanism which get checked quite a few times. So make sure that you do enough practice writing it. Okay guys, that's it.